Today on Let's Talk Chemistry, we're going to be talking about aqueous solutions.
In chemistry, an aqueous solution is one in which water is the dissolving medium, or like the solvent. Water is a very, very effective solvent for ionic compounds like salt, which is sodium chloride, NaCl, and with that it creates an electrolytic substance. So the solvation process occurs when you put the salt in the water, and the positive and negative ends of the water attract the positive and negative ion. So the negative side of water attracts the sodium, and the positive side of water attracts the chlorine, and it pulls them apart. This happens in ionic compounds. However, most molecular compounds, when they are put in water and dissolved, molecules remain intact and no electrolytes formed. However, there are a few exceptions, like acids such as hydrochloric acid, which ionizes or dissociates into its ions. So we have two electrolyte categories. We have a strong electrolyte and we have a weak electrolyte. Strong electrolytes exist in the solution almost entirely as ions, like salt or sodium chloride. It goes in the solution, completely breaks apart, it's almost entirely its ions. Weak electrolytes, however, exist in a solution mostly as molecules with a very small fraction as ions. There are three types of aqueous reactions I'm going to talk about. One is a precipitation reaction, which the result is the formation of an insoluble product known as a precipitate. Now, there are some basic rules to show whether a substance is soluble in a reaction. In a precipitation reaction, it's often really important to know whether the dissolved substances in the aqueous solution are molecules or ions. So a complete ionic equation, one that shows the ions present in the solution, is often used instead of a molecular equation, which just gives the chemical formula of the reactants and the products. Once the reaction is written as a complete ionic equation, the spectator ions, or the ions that appear in identical forms on the reactant and product side, they are removed, and all that is left is the net ionic equation without any of the spectator ions. So that's basically covering precipitation reactions. Acid-base reaction. An acid is a substance that ionizes in an aqueous solution to form hydrogen ions. A base, on the other hand, is a substance that will accept hydrogen ions and or produce hydroxide ions in a solution. Both can be strong or weak. If it ionizes completely in the solution, it's strong. However, if it only partially ionizes in the solution, it's generally considered to be weak. Using the knowledge we have of strong and weak acids, we can make predictions to determine whether a substance will be a strong or a weak electrolyte. So with ionic substances, it's always going to be a strong electrolyte. However, with molecular substances, a strong acid will always be a strong electrolyte. However, a weak acid or a weak base will be a weak electrolyte, and then all the other compounds are just going to be non-electrolytes. So when we take an acidic solution and mix it with a basic solution, we get a neutralization reaction. Generally, this reaction will produce water and a salt. However, when a carbonate or a bicarbonate reacts with a acidic solution, a gas, carbon dioxide, is one of the products. Oxidation-reduction reaction, or a redox reaction. This reaction is when electrons are transferred from one substance to another. So one substance will lose electrons, one substance gains electrons. Now, when a substance loses electrons, that's called oxidation, and that substance is oxidized. When a substance gains electrons, that's called reduction, and the substance is considered to be reduced. To keep track of moving electrons in a redox reaction, we assign oxidation numbers to the elements, atoms, compounds in the reaction. Atoms in their elemental form, like O2, will always have an oxidation number of 0. Monatomic ions will have the oxidation number that is same to their charge, like potassium, which is K+, will have an oxidation number of +1. So all of the group 1 elements have an oxidation number of +1. For nonmetals, the oxidation number is usually negative. To oxygen, we assign a oxidation number of -2 unless it's in peroxides, in which it gets an oxidation number of -1. Fluorine will always have an oxidation number of -1, and And hydrogen will have an oxidation number of -1 when it's bonded to metals, and it'll have an oxidation number of +1 when it's bonded to non-metal. With these oxidation numbers, if you have a compound and it's a neutral compound without a charge, the sum of all these oxidation numbers will be 0. However, if the compound has a charge, the sum of the numbers is going to be equal to that charge. This redox reaction is used in a special reaction called a displacement reaction, when a metal reacts with an acid or a salt, and one of the compounds in the reaction is oxidized.
For instance, if we react magnesium with hydrochloric acid, we get magnesium chloride and hydrogen gas. And in this reaction, we see that the magnesium, which previously had an oxidation number of 0, has changed to have an oxidation number of +2. And the hydrogen, which had a previous oxidation number of +1, has gained the electrons and has an oxidation number of 0 now.
In order to tell whether a certain metal will be able to be oxidized, we use what's called the activity series, which is just a list of elements. So in the activity series, any metal can be oxidized by any element below it in that chart. So when we're discussing these reactions, like the precipitation reactions and the redox reactions, it's important to know the concentrations of the solutes in the solution. It is important to know the concentrations because the behavior of the solutes often depends on that. So in order to express concentration, we use the term molarity. Now molarity is simply moles per liter. For instance, a 1 molar solution of NaCl or salt is 1 mole of salt per liter of water. Now when you put the salt in the aqueous solution, it will break apart and it will become 1 mole of sodium per liter of water, as well as 1 mole of chlorine per liter of water. So once you have a concentration like of salt or whatever, if the concentration in the water is too high, like if there's too many moles per liter, you can dilute it by adding more water to the solution. So the amount of water you need to add to a specific concentration of solid, or the amount of solid you need to add to a specific concentration of water, can be found with a pretty easy chemical equation, which is displayed on the face. The equation is the moles of the concentrated substance times the volume of the concentrated substance equals the moles of the desired dilution times the volume that you want for the desired dilution. So this equation can be used for any solution as long as the units on both sides are the same, as long as it's liters and liters and moles, as long as everything like that is the same. If the concentration of a solute in a solution is unknown, you can use titration to find the concentration. In this process, you take a specifically known concentration and you add it to the unknown in order to try to get them to balance. The known concentration of solid is slowly added to the unknown concentration, like if you had an acid and you wanted to know how much a concentration of the acid you had, you'd slowly add a concentration of base that you know. You'd keep track of how much you added, what the concentration was, and so you keep adding the known concentration until you reach the equivalence point. And you put an indicator in the titration in the unknown solution so that when you reach this equivalence point, when the amount of acid and the amount of base balance out, the indicator will change colors and let you know. And so that's about it for aqueous reactions.